Hey everybody, it's Randy with Lowbuck LS here again, and today I'm going to show you how to build a flow bench to test fuel injectors. I'm going to be testing these fuel injectors that I got from the junkyard. If you watch like 2 videos back or so, when I went to the junkyard to get these. So I'm going to build a test stand or flow bench to test these injectors, and then when I decap them, I'll test them again, and I'll be able to see if they're all flowing relatively the same. So I'm going to use this to hold the fuel, and so first thing I need to do is build some kind of rig to hold the injector in the bottom of that. So I already got started here. I'll come up a little closer to the camera. So I took, this is, the lighting's messing me around here. This is like a regular 1/2 inch NPT pipe plug, one that hasn't been drilled. But this one I've already drilled. So I just drilled through it with like a regular 1/2 inch drill bit. And then, like, this is the O-ring doesn't quite fit in to that 1/2 inch hole. So I took a step bit and drilled it one size bigger. So, man, I gotta fix the lighting in here. The camera's doing weird things. But anyways, I took it one size bigger with the step bit. So now the injector fits into that 1/2 inch NPT pipe plug. So now I'm gonna build some kind of clamp or bracket, because there's gonna be 58 pounds of fuel wanting to press the injector out of the hole. So I've got to build some kind of clamp to hold that injector into that pipe plug. So that's what I'll get started on now. Okay, so to make this clamp that's going to hold the injectors into the bottom of the test chamber here, I've got some, it's 3/4 by 1/8 flat bar. So I'm going to cut 2 pieces of that 2.5 inches long, and then that's going to make basically the 2 pieces that are going to sandwich the injector. There's going to be one on top of the injector here and another one on the bottom of the injector here. So that's what I'm going to do right now, is cut 2 pieces of 3/4 inch by 1/8 flat bar, 2.5 inches long. So I'll come back once I've got those cut. Okay, so I got my 2 pieces of flat bar here, 2.5 inches long. Now on the one that goes on the bottom, I'm going to drill a hole 3/8 of an inch from each end and 1 hole in the center. And the one that goes on the top of the injector, for now I'm just going to drill the 2 holes 3/8 of an inch in from each end, and then I'm going to weld this to this 1/2 inch NPT plug, and then I'm going to drill it through once I've got it welded on. So I'm going to mark these out here and drill some holes. So I got my holes marked out here. Now I'm just going to center punch them and drill them out. And again, this piece will be the bottom, and this piece will be for the top of the injector, but I'll drill that out once I get it welded to this piece. And yeah, here the lighting is better. You can see that step that I was talking about, where the main part of the hole is 1/2 inch, and then I took that step bit and notched it out by the top there, so the injector will fit in just like that. Okay, so you can see I've got these holes drilled here. I should have almost used a thicker piece of metal, because that hole for the injector is getting pretty close to the edge. So I probably should have used like a 1 inch by 1/8 flat bar, but I don't have any, so we'll stick with this 3/4. So now I'm going to weld this piece on top of here and then get this drilled through here. Okay, so now I've got this 1/2 inch pipe plug welded to my piece of 3/4 by 1/8 flat bar. Now I'm just going to drill through here and make a hole for the injector to go in.
Okay, so as you can see, that was a bit of a struggle to drill through, but yeah, like I said, I drilled through this way with the 1/2-inch drill bit, and then same deal again, I had to go in with my step bit here and take it up one size past 1/2 inch, probably 9/16 I'm guessing. So now the plan is I'll be able to stick the injector in there like that, and then put this piece. It's hard to hold the camera and do stuff with one hand, but anyways, you get the idea. The injector is going to sit in there, and then this piece is going to sit in there to hold it in place, and then I got some 2.5-inch 1/4 by 1/4 inch bolts here that will hold it all together. So right now I'm going to stick these bolts in here and just tack the heads of the bolts to the piece of steel here to hold them in place. Okay, so I got those bolts in here and pretty well have this injector clamp finished. That's kind of what I had in mind there, and the injector is just going to basically clamp right in between those two pieces. So now I'm ready to put it all together and try and make this injector flow bench. Okay, so I decided I'm going to put a valve underneath my test chamber here, because otherwise when I'm done testing, when I go to pull the injector, all that fluid I have in there is just going to run out. So I'm going to put a 1/2 inch by next to close pipe nipple in the bottom of this chamber, and then a 1/2 inch 1/4 turn ball valve, and then thread my injector clamp into the bottom of that ball valve. So I'm going to get that all put together right now. Maybe I'll try this time-lapse thing. I'll let you guys watch while I work, I guess. Of course, now I feel like there's people watching me while I work, so now I'm all like fumbling, and but oh well. It's funny, there's not another person in the shop, but I feel like somebody's watching me. Alright, there we go. So there is the bottom end of the test chamber there. I've got my test chamber, which is basically a piece of 2-inch pipe, then a 1/2 inch next to close pipe nipple, 1/2 inch 1/4 turn ball valve, and then my injector clamp assembly that I built. Okay, now I'll show you guys how it's going to work with an actual injector. So there's that clamp I built. Injector is going to go in that hole there, and then this piece is going to go on here. I should have almost used bolts that were one size shorter. I was going to have a nut on the inside here, but that's not going to work. And yeah, then I'll just thread the nuts on here. And then snug them up. And that should hold that injector fairly securely in place. When we've got 58 pounds of fuel pressure in our test bottle here, the injector's not going to go shooting out across the room. Like I said, these bolts are a little long, so I think I'm actually going to trim them up a bit here with a cut-off disc. So we'll get those cut off, and then I'm going to build a stand for it to sit on. This is going to be the base of it, and then I'm just going to weld a chunk of steel, and this is going to make a stand for it. And I got a graduated cylinder from Amazon, so that's going to sit on the stand, and then I'll make it so this test chamber will sit above this graduated cylinder. So I'm going to go see what I got for steel in the shop here to make a stand for this thing. Okay, so I found a chunk of, I think it's 1 inch by 2 inch rectangular tubing here. So I'm going to weld that onto this piece of C-channel sticking up right about here, and that'll hold the test rig, and my graduated cylinder will sit on right there. So I'm going to get this stand welded together here. Okay, so you can see I got this chunk of rectangular tubing welded to my C-channel base here. Now I'm going to take a piece of this, it's like electrical strut, and cut it up. Excuse me. I got a sneeze. Must be allergic to welding. So anyways, like I said, I'm going to cut up a couple chunks of this, I think it's called Unistrut, or it says Super Strut in there, or Cantras is another brand. I'm going to cut it up, weld a couple chunks to there, and then use these clamps that'll hold this test chamber into place on the stand here. So I'll get these pieces cut up and welded to the stand here, and get back to you shortly. Okay, so I got my stand built. It's turning out to be taller than I expected, but anyways, you can see where I welded that rectangular tubing onto the base. There's my graduated cylinder for measuring how much the injector is putting out, and there's those two electrical strut with Cobra clamps, or they're called, or P clamps, some people call them. So basically, mechanically, it's pretty much done. I gotta run pressure to the top of it, and this gauge is in kPa, but 400 kPa is 58 psi what the Gen 3 LS engines run at. So I'm gonna figure out how to run pressure up to the top of it there, and we'll resume the video shortly. Okay, so I put that injector test stand on the floor to make it easier to work on it. So now I'm gonna rig in, basically I'm gonna put this swedge lock tube fitting in the top here, and then I'm going to put a pressure regulator tied into that T-fitting to supply pressure to the whole assembly, and then I'll put a valve and basically like a big funnel on top to dump the fluid into it. Okay, so I've got this put together here. I put that T in the top of the chamber. I've got a regulator that's set to 58 pounds. I got shop air supplying that regulator, and then I've got this big, I think it's called a swedge, from 2-inch MPT to 1/2-inch NPT, but basically I'll just dump my mineral spirits in there to fill it up. So I think I'm pretty well ready to put some fluid into it. Okay, so I'm going to fill this up with fluid. So first I'm going to verify that, I guess the gauge is out of camera range here, but verify that there's no pressure on the chamber, because otherwise you'd have 58 pounds blowing out of here when you open up this valve. And in my graduated cylinder here, I'm going to dump in 1/2 liter of mineral spirits. Apparently it's leaking all over my workbench, but oh well. And then we'll dump this 1/2 liter into our test rig. Oh yeah, I guess there's no vent in there, so it's going to take a bit for it to bubble down through. Okay, so that's empty. We've got this chamber loaded up with mineral spirits. We can close that valve, and I'll go turn on the shop air, and then I'll set it up on the workbench, and that way we can see the business end of this thing. So, be back in a second. Okay, so I'm ready to do some test hits on my flow bench, fuel injector flow bench, or test stand, or whatever you want to call it. So I've got the shop air hooked up, filled with mineral spirits, 400 kPa on the gauge. I got this All Sun EM276 injector tester hooked up to a battery, and I'll put a link in the description. There's a guy that did a good video review of this in the description, and I'll put a link if you. It's like 30 or 40 bucks on Amazon if you're interested in buying one for yourself. But and then I've got battery to power everything up, and it's hooked up to a battery charger to keep things charged up here. So on this fuel injector tester, there's 4 modes. So mode 1 is a pulse of 1 pulse of 250 milliseconds. So we'll I got her in mode 1 here, and so every time I press the button, it does 1 pulse of 250 milliseconds. So you can see here I'm pressing, can't zoom out far enough, but every time I press the button, that thing does a pulse of 250 milliseconds. Now to switch modes, you have to undo the battery clip, basically turn off the power. Now let's try mode 2. So mode 2 is 50 pulses of 7 milliseconds each, so here goes with that. So this would be a good way to test your I guess it'd be your dynamic flow rate. You could hit the button a set number of times, hit it 50 times or whatever, and see how much fluid's in your graduated cylinder. Now let's try mode 3. So again, you gotta pull the battery clip off. And mode 3 is supposed to be 100 pulses of 3.5 milliseconds each. So let's try that. So there you go. Each time I press the button, it's doing 100 pulses at 3.5 milliseconds. And then there's one more mode, that is mode 4, that'll do continuous 50 pulses of 7 milliseconds each, about every second and a half, I guess, every 1450 milliseconds, and it'll just keep going like that. So let's give that one a try. So here we go. So it's basically just running continuous at 50 pulses of 7 milliseconds each until you hit the pulse button to stop it. So that will work good for the dynamic flow testing, but I also want to rig something up for static flow testing. So I've got this, again, it's a little timer I bought from Amazon, so I'll put a link to it in the description below. I want to get that wired up now. So basically this thing, it doesn't have like a static testing mode where it just holds the injector wide open for 30 seconds or a minute or whatever. And you could rig it up with a push button and, you know, just time your stopwatch, hold the push button for 30 seconds, but the problem would be you're not going to be consistent and do it exactly 30 seconds every time. So I want to I'll wire up a circuit now, see if I can get this timer working, so you can set in however many seconds you want it to fire that injector for, and it should do it the same every time you press the button. That way you can test all 8 injectors, or compare a set of regular injectors to decapped injectors or whatever. So now I'm going to work on getting that wired up. Okay, so I got this little Amazon timer wired up here, and it's kind of funny looking at the instructions. I noticed one thing. It says, this is interesting. This product can be used in raft fishing machine, slow down machine DIY. So I don't know what a raft fishing machine is, but I kind of want to find out. It's weird. It's almost like the people who wrote these instructions can't speak English or something. But anyways, here's a little diagram of how I wired this up. There's 4 terminals on that timer. So I took positive power from the battery to the terminal called VCC, and then I jumpered over to terminal S1, and then negative from the battery goes to ground. So basically VCC and ground are your power supply to this timer, and then S1 and S0 are a set of contacts that close when the timer is active. Or there's a bunch of different modes. Like if you look at the instructions there, I'm using mode this P1-1, so after the time delay the relay releases. So as the timer's timing, there's continuity between S1 and S0, and it's going to fire your fuel injector, and then the negative of the fuel injector is just tied in common with the ground here, or you could take it right to the battery. But so yeah, basically VCC and ground are your power to power up the timer, and then when the timer's active in this mode, there's continuity between S1 and S0. So I'll show you how it works here. So right now the timer is set for 5 seconds. So I've got fluid back in the chamber there, 400 kPa of pressure on it. So the other thing I noticed is there's fluid like spraying out of here, so I've got it set down as low as possible so that injector's firing right into the graduated cylinder, but there's still some spray coming out of here, so it's not ideal, but it'll work. So right now, like I said, I've got this timer set for 5 seconds, so when I hit this restart button, our injector, let me try and get back a little bit here, our injector should fire for 5 seconds, and it is. And I'll do it one more time here while looking at the timer here. You'll see it count down. Actually, you can't see it real well there. I'll hit her again here. The lighting or something's weird. You can't see the numbers very well, but and you can see that stuff kind of spraying out of the top. So not sure how to get around that. It'd almost be nice to have a sealed chamber up here. Like maybe I need another one of these for the injector to spray into, but then I don't know how you'd measure the level. But anyways, now I'm gonna go do some math and figure out how to convert like pounds per hour into milliliters or whatever, and actually see how much these injectors flow. They haven't been decapped yet. They're supposed to be, I think they flow like, supposedly they're the flex fuel injectors out of O2 Tahoe. So I think at the 58 or 400 kPa, I think they're supposed to flow 36 pounds per hour. So I'm gonna go figure out how many like milliliters per minute or whatever that is. So be right back after I've done some math. Okay, so from what I have gathered from Google, if I do a 1 minute test, the number of milliliters that are in my graduated cylinder here, if I divide that by 10.50 milliliters per minute, that'll give me the flow in pounds per hour. So I'm set up here to do a 1 minute flow test. I just put a rubber glove and like zip tied it around the top of my cylinder to keep the vapors from like spraying out. And another thing I discovered with this little Amazon timer is when you set it for a different time, you have to disconnect the power to the injector, because as soon as you're done setting the time on it, it'll fire that injector for whatever amount of time you've got set. So right now I want to set it up for a 1 minute test. So I've got the wire to the injector disconnected because it's going to fire So to change it, right now it's set for 5 seconds. So to change it to 1 minute, I just press this set button and it'll start flashing. And then I take the up arrow and set it to 60 seconds. And then it will flash for 5 seconds or so, and then it'll see now it's taking it and it's firing the relay and counting down for 60 seconds. So I'll just wait for that to count down, and then it'll be ready to then when we hit this, what's this button called here, restart. Every time we press that button, it'll fire for a minute. So just wait for that to time down, and then we'll do our test. Okay, so I'm ready to start my 1 minute flow test. I've got that injector wiring connected back up, and so when I hit this restart button, it should start a 1 minute flow test on this injector. You can see it counting down there, 50, 49. I don't know if maybe you can't really see it that well with the lighting or whatever, but that rubber glove idea seems to be containing the overspray fairly well. And our pressure is still, it's dropped slightly below 400. We got about 20 seconds left on our timer here. I'll just zoom out a little bit so you can see the whole operation here. And it is done. So it looks like we've got about 200, hang on here, so that's 250, that'd be 275, so 280 milliliters in a 1 minute test. So let me just do the math on that. Actually, we'll fire up the calculator here. 280 divided by 10.5 equals, so according to this math, these injectors are flowing at about 26.66 pounds per hour. Now, I just got this number off of Google, so I'm not 100% sure it's correct, but based on this initial math and this flow test, these injectors that I got from the junkyard are flowing 26.66 pounds per hour at 58 psi or 400 kPa. Okay, so there you have it. We have a functioning fuel injector flow bench, or a flow test stand, or a way to flow test your injectors that you grabbed from the junkyard, or if you've decapped them, or even if you want to test your injector dynamics, or basically any fuel injector you should be able to test with this flow test rig here. So next step is going to be, I've got some basically a repair kit for all 8 of these injectors. It's got O-rings and filters. So next thing we're going to do is decap these injectors. I think based on what I've seen here with the flow, they're not going to flow enough without decapping them. So stay tuned. Next video we're going to decap these injectors and put these repair kits in, and we'll flow test them all and make sure they're all within an acceptable range of each other. And yeah, so when I get that next video done, I'll put a link to it here, but for now that's all for this week. We'll see you next Tuesday at 7 o'clock for our next video. Talk to you soon.